Sorry, Aiden. Forgot to hit record. You know all of this though. Just pause and write everything in and you'll remember it, I promise. Hopefully he's gonna remember, right guys? He should. Okay. So yeah, let's talk through how we're gonna do this with the table and with the calculator. So these next examples, we're gonna go through this with using the table and with the calculator. So if we're finding a percent or an area under the curve, the directions might say, think about all of the different ways you heard me mentioning that. What's the probability that it's at this point in less than, or that this point in greater than, right? Find the percent or find the area. So there are a lot of different ways of basically saying you're gonna do that same thing, right? Hopefully that sounds familiar. So if we're gonna find the percent under a table, then the first thing that you're doing is finding that z-score. I'm gonna make this a little bit bigger. So find your z-score. Remember, whether it's a positive or a negative value matters. It's very important, right? Your negative or positive is really important. And then look on table for the column and the row. We're going to look at an example of that here in just a second. And I'm going to grab calculator too because I have to see this. I don't remember this one off the top of my head. I always have to look at this. Okay. On the calculator, yeah, let's take a look. Where are we? What is that? Menu, and then 6 and 5. Yep. Okay, so it's menu 652. If we are looking at our norm CDF and our inverse norm. So for finding the percent or the area under the curve, for that particular one, you're doing the norm CDF. I'm not sure, did I share this with you guys in stats at all?
I never did the calculator stuff in stats.
Okay, I think I decided I just wanted to stick with the table. So I do want you guys to see how you do with this on the graphing calculator as well. So you've got the table to back up, but if you want to do this on the calculator, you can too. So you strictly used table also, Kaden, or did you use the calculator also?
We did the table, but we had a different calculator, just like N1 and N2, and then like it's columns, and then
Okay. Okay. So for the calculator stuff, we're going to, did everybody get their menu 652? And what you're looking for is that norm CDF. So the way this is written is you put your lower bound and then you put your upper bound. And the way, like it used to be, old calculators, it had it in a little bit different format where it was just all one long expression that you had to do. The nice thing about the graphing calculators now is that it actually puts it in the order. So it's asking you for your lower bound, and we'll talk about that in just a second, and then your upper bound. And those values are going to be given like in the problem, right? So we'll look at that also. And then it asks for your mean, and then it asks for your standard deviation. So, okay, typically, I don't know, when you went to your norm CDF, what does it say for the lower bound? Does it have something in there? I'm sorry?
Negative infinity.
It does,
Mine says negative 9e9.
999, okay.
E.
So the calculator gets a little bit glitchy. Sometimes the negative infinity is going to work okay, and then other times it gets glitchy. So if the negative infinity does not work, then you're gonna go back and just put in you're gonna type in a negative 9999, just put in a big number basically to say we're starting way down low and we're going up to this particular point, okay? So I'm curious when we plug into the calculators how this works for everybody.
Is that always going to be our lower bound?
Well, we're always gonna put our lower bound first and then our upper bound. So here's the difference, Riley. Like in some instances, right, we're asked to find the area under the curve and it's from here and lower. So if that's what we're doing, then our lower bound is that negative 99999 or negative infinity. And then we're going up to whatever this place is.
Okay.
So that's gonna be our lower bound and our upper bound. But let's think about this for a second. We might also be asked to figure out from a particular location, the area under the curve going from that point and higher. And if that's the case, then here's what our lower bound is, whatever that value is, and our upper bound is positive infinity. So it's gonna go up to that 9999999. So it's going up to infinity or that value there. Does that make sense? Is that what you were asking, Riley?
Yeah. Well, I just didn't know like if a problem like would give us a lower bound or if that's like always going to be.
If we're finding the area under the curve or that percent, then if it's saying it's from that point and lower, then the lower bound's gonna always be that value up to whatever. If it's saying from a particular point, we want the area under the curve of greater than whatever a particular place, then our lower bound is whatever that value is, and then we're going up to positive infinity, basically, right? Guys, does that make sense? RJ, yes? Ian? Jada? Noah? Okay. All right. Kaden, you have to kind of let me know what you know and what you're not so sure about either. But yeah, it is helpful that you had a little bit of statistics already. So, okay, let's take a look. So using that summer camp example, it says a certain ride requires riders to be at least 51 inches tall. What percent of students will not be able to ride? So that means we are looking at, we want to, the people who are not going to be able to ride are less than 51 inches, right? So we're basically trying to figure out, if you think visually of what's going on, whew, wow, that was really bad. If you think about what's going on, somewhere here we have 51 and we're looking for what percent of is lower than that, right? Okay, so if we use the table, I'm gonna make this a lot bigger so I can fit this in here. If we use this z-score and the table, then we're gonna say observation minus mean all over standard deviation. And we get that the z-score then is negative 1.67.
Wait, where did you get the
56 was our mean.
Oh, is it from the
It's from that previous
Oh, okay.
problem. Yeah, that same problem. Yep. So observation minus mean all over standard deviation. We get that negative 1.67. And so then we are looking on this. So, Brianna, I want to help you with this. So it's negative, which means it's to the left. And you're looking for a negative 1.6, but then you've got to go over. If you notice, here's where the 0.07 is. So you're looking for that intersection. So where is it here? It looks like. Is that right? I'm looking upside down, so I might. Okay, so it looks like it's what was it, 0.0475? Okay, so that corresponds to what is that? 0.0475, which means 4.75% of the students would not be able, or 4.8, whichever way you want to write it, if you were rounding. I like the 0.75 personally. Okay, but let's try this on the calculator. So if we were using the calculator for this other method, then what we're gonna do is we're gonna do the norm CDF, and we're going from negative infinity, which if you have that negative infinity in there, keep that, because I wanna see that if it works or not for you, or if it gives you some weird error message.
Okay.
Okay, because sometimes I don't know what the deal is. For some, it seems like it works, and then for others, it doesn't. Okay, so negative infinity, that's our lower bound. Our upper bound is that 51, and our mean is 56, and then our standard deviation is 3. So if you plug in that information, that gives me, okay, RJ, did you get it? Okay, Ian, well, yeah, clearly you didn't, because you don't even have your calculator out, sweetie. Grab your calculator. Okay, Ian, yes, no?
Yeah, I got 0.04, so such a.
Great, okay. Yeah, RJ, try this. Braden, I know you're good. Noah, did you get it?
Yeah, bring them.
Okay,
And then,
awesome. Jada, you got it? Okay. Did your calculator say negative infinity or the negative 99999? The last one. Okay, yours said, okay, with your infinity, did that work?
Yeah, I got 0.
You got that?
Yeah.
Okay, all right. And I did I write that right? Yeah, I did, okay. So this tells us that we're at 4.779%. So they're a little bit different, but close enough, right? Okay. Okay, what percent of students are greater than 58 inches tall? So if we are doing that with our Z table, I want to kind of write these out. What percent of students are greater than 58 inches tall? So we're doing Z is equal to 58 minus 56 all over 3. And that gives us 0.67. We have to be careful with this, with our table. So if we go to 0.67, that is 0.7486. But what do we need to do, because it's saying greater than 58 inches tall?
subtract 1.
Yeah, we're doing 1 minus that, right? Good, excellent. That's the key, is remembering that 1 minus because of the greater than. So 1 minus that gives us, what is it, 0.2414? In other words, 24.14%.
Okay, 25. Wait, 25. 2514.
2514? Okay, sorry. I'm trying to do the math in my head real quick, and I'm not running on all cylinders this morning. Thank you. Okay, Brianna, I want to make sure you follow why we just subtracted from 1. The way this table is set up, it's telling us the percentage of values. It's a cumulative up to that particular point. So it's basically telling us from that particular point and lower,
Okay.
okay? However, when it asks a question of like this, where it's saying at this particular point and higher, what we have to do is basically figure out what this percentage is and then say, okay, it's the other part, so we have to do 1 minus that to figure out the other.
Okay.
Does that make
Yeah.
sense?
Yeah.
Okay.
So you always subtract 1 if it says greater than?
If it's greater than, higher than, longer than, yes,
Okay.
and that type of thing, you're gonna do 1 minus that, okay? All right, and Braden, I guess I should check with you. You said you did a little bit with this table, correct?
Yeah.
Okay, all right, let's talk about how we're gonna do that on the calculator. So on the calculator, you would do norm CDF. So how do you do that? What's the key sequence there? Menu, 652, good. Okay, so you're gonna do norm CDF, and then you're going from 58 and higher, so you're going up to infinity. So that's kind of the difference in how you plug that in. And then you're 56 and you're 53. So I wanna try that here, menu, 652, 58. And just type in a 999999 type thing. And then, oops, all right, it didn't like that. All right, calculator. And then what was this, 56 and 3, and okay. All right, so that gives us it gives us a 25.2492%. Okay, Ian, you good with how to plug in on the calculator?
Yeah.
Okay, RJ? And that was the first part. We're gotta look at the second part where it's asking between. Okay, Noah, you're good? Yes, Jada? Riley? Okay, Kaden, I think you are, yes, no? So I will tell you that between using the table is a lot more work. The calculator, it goes a lot quicker and it's a lot faster. So, but I do want you to think about what we have to do for each of those. So we're gonna talk about that. Okay. I'm sorry? Okay, so for your lower bound on this one, because we're going from 58 and higher, 58 is your low, that's your your lower bound. And then for your upper bound, just type in 9999999 in place of that. And then, nope, you want to change these. That's part of it too. If you keep the 0 and 1 there, RJ, then it's going to give you the scores as a z-score, not as the actual values. And then that was, what was our meeting, 56 and 3? Okay. Awesome. Okay. Okay, let's talk about how this works if we're doing a between, if we're using the table. So if we're using the table, then we have to find z-score for 52. And what does that give us? Negative 1.33. And we have to find the z-score for 54. Negative 0.67. And then we go to our table, and we are looking for those two z-scores. So negative 1.33, which gives us a 0.0918, and a negative 0.67, which gives us a 0.2514, and we need to subtract those two. So check and make sure you understand how to find on here. Okay, so that's using the table. I want to talk you through how you do this with the calculator, and you're going to love this. It's much nicer and faster and easier. Okay, if you're doing this on the calculator, just think about the fact that you're still going to do a norm CDF. Our lower bound is 52, our upper bound is 54, and then we have our mean and our standard deviation. And that gives us, what does that give us? About 1.161, so 16.1%. I didn't do the math here. What does that give me? I don't want to make another stupid math mistake, so I'm going to put, I don't have that written here for whatever reason.
I got 0.3482, but I think I really,
For this one,
yeah. I subtracted 0.0918 from the top, and that was a negative. Like, never mind.
say that again.
Nothing.
Did you just plug in wrong?
Yeah.
Okay, all right. Okay, let's go back. This last question has to do with now thinking about how many sixth graders there were. So if you notice, it says approximately how many of the camp's 220 sixth graders will and will not be allowed to ride. So we figured out up here that about 0.048 can't ride. So if we take 220 and we multiply by 0.048, we get about 10.56, so around 11 kids, about 11 kids are not gonna be allowed. That does not look like an 11.
Wait, where did you get 0.0?
We did that in this first part up here. We got that 4.75 or that 4.779. So I'm just rounding that to 4.8 to make my work easier here. So that answer is from here. Let me draw an arrow there. Okay. Okay. So keep in mind, this is to help find a percent. So now we want to go, if we want to find a z-score. So if we're doing this with a table, remember we go to what I call the meat of the table, and we find the closest percent, and then we look for the corresponding z-score. So that's the process that if we are using the table. If we're using the calculator, it's called inverse norm. So you just have to remember the key sequence for that. So let's talk through these. Okay, so finding z-scores or actual values from a percentile. So, find closest percent in meat of table, find corresponding z-score, and then plug into your formula. Here's where you're working backwards, right? Okay. On the calculator, this is, I think, a lot easier also. So you're gonna do menu 653. So if you look at that, all right, Ireland. So menu 653 is inverse norm. And so, if you notice what it's asking for there is your area and then your mean and your standard deviation. So for your area, you want to do this as your percent as a decimal from the left side. I don't know if I'm explaining that very well, so we'll look at an example here of how you're plugging in, okay? So let's do each of these as well, kind of in both formats. So find the height of a camper at the 30th percentile. So if we're using the table, that means we're looking for as close to 30% as we're gonna be able to find. That obviously has to be to the left-hand side here, right? Because middle is 50%, so 30% has to be over here. So you're looking over here for as close to 30% as you can get. And that looks like it's gonna be negative 0.52. So the z-score is negative 5.2. And then we're gonna say x minus 56 all over 3. We multiply by 3, we add the 56, we get x is 54.4 inches. Now, if we are using the calculator here for this one, then we're gonna do this inverse norm. Right, so we're gonna do inverse norm, and then because it's the 30th percentile, it's gonna be 0.3, and then our mean, and then our standard deviation. So 0.3 to say 30th percentile. Come on, Ireland. Oh my goodness. Okay, and what did you get for that? You get 54.4268 inches for that one, right? Okay. Let's talk about this. Read carefully. This next one, it's saying at the top 10th percentile. So really what that means is that we're at the 90th percentile. So if we're plugging into the calculator, then we're going to do inverse norm of 0.9 and then the 56 and the 3. And just for time's sake, I want to have you just do that rather than with the table. Process is going to be the same though. You'd look for where 90% is, find that z-score, and then you're working backwards. All right, for that one, we got, what, 59.8 inches. I'm not even gonna worry about this last one. All right, I was hoping, I wanna try the Kahoot, I think. We won't worry about the workbook stuff, but I do want you to try that, do that worksheet, okay? And we will go over that next time. So don't worry about the workbook. I will take that out, but I do want to try this Kahoot, okay?